So hello boys and girls, welcome to the 26th lecture of this course which is named Chemistry. The course code for this course is CH101 for odd semester and CH201 for even semester, right? This is G Chakraborty and you are watching the lecture 26, that is part 2 for the module water. Okay. Now in the last lecture we have seen that water is a very precious resource for us. Water is life, and in absence of water or in crisis of water, what type of problems we face. Also, we have seen a very important water quality parameter, that is hardness of water. We have seen why hardness is caused, which ions are responsible for temporary hardness, which ions are responsible for permanent hardness, how the temporary hardness of water can be removed, and how permanent hardness of water can be removed, right? These things we have seen in our last lecture. Now, in this particular lecture, what we are going to see? We are going to see the following topics, but before that, let us remind again, this is water part 2, and the lecture highlights for this particular lecture are nothing but water quality indicators, the physical indicators, the chemical indicators, the biological indicators, followed by a very important parameter, that is salinity of water and alkalinity of water, right? So these are the topics that we are going to see in this full and final lecture of water. So let us see what the next slide has. You can see the topic of this particular thing is environmental water quality. Okay. Now question arises, what is the meaning of this point, environmental water quality? What is environmental water quality? You know, water quality is very important for us because, see, as we all know that water is the basic need of all human beings, and water is considered life. Okay. Yes, it's true. Water is life. Without water, we cannot live, right? Without drinking water, without using water, we cannot live. But how many of you have seen the movie Life of Pi? How many of you have seen? I think majority have seen, right? I have also seen. In that particular movie, we see that the person, the hero, I'm not talking about Irfan Khan, right? The boy who played the character of the hero, right? That particular person, he was stuck in the boat with Mr. Sher Khan, right? And for months, I get, there was plenty of water around because they were in the sea, plenty of water. But is that water drinkable? The answer is no. Seawater is salty in nature and it is not drinkable, right? Number 2, under that condition, when we say the water around us is good and water is life. See, the fact is, yes, water definitely is life, but if it is in very excess quantity, then it may take the life, right? It may take life instead of giving life. Okay. So what is the quality of water? See, suppose we are having a drain. We are having a drain full of water in front of us. Now you are very much thirsty. So can we drink water from the drain? Again, you will say no. The fact is, why we are saying no? Why we cannot drink water from a drain? The answer to this question lies in the fact that the water quality is not good. Okay. Now, in order to say that the water quality is not good, we need to see what are the parameters that determines the quality of water. Yes or no? It is very important to see that what are the factors that determines the quality of water. Okay. Those factors we will clearly explain in this particular lecture. Okay. So let us see what is contained in this particular thing. You see, water quality refers to the chemical, physical, and biological and radiological characteristics of water. Okay. Now, chemical means what different type of chemicals are present in water. Physical means what is the density, what is temperature, these sort of things. Biological means what biological organisms are present in water and what type of needs the water will satisfy. Radiological means if we do radioactive studies or radiological studies, then what changes we will see in the quality of water, right? So these are the 4 things. It is a measure of the condition of water relative to the requirements of one or more biotic species or to any human need or purpose, right? That means the quality of water will be judged on the basis of on the basis of the fact that for what particular work you are using that water. Okay, so in terms of our use, the quality of water is determined. For example, suppose we want to take water for washing our clothes, right? We want to take water for we want to use water for washing our clothes. Now, under that condition, we will try to have the water which is not hard. We will try to have soft water. Means we want that water which contains less amount or no amount of dissolved salts of calcium and magnesium. Why the fact is like that? If we use hard water, then what will happen? The scum, the gummy mass will be formed on the object that we are washing, right? On the cloth that we are washing, and the brightness, the sparkle of the cloth will go off, right? That's why for that particular purpose it is said that if the water quality is soft, then it is good quality water, right? For washing purpose. Now if we consider drinking purpose, right? If we consider drinking purpose, then we will say that fresh water or sweet water is better than salty water. Why? Because we cannot drink salty water, but we can drink fresh water, right? So depending on the human need or purpose, the quality of water is judged. Okay. Now it is the most frequently used by reference to a set of standards against which compliance generally achieved treatment of water can be assessed. Okay. Now there are a set of standards with respect to which we will see that the water quality is good or bad, because without a proper set of standard, it is not possible to rectify that what quality of water we are having, to understand what quality of water we are having, right? So that's why there is a particular scale, a particular standard which will be used to assess the quality of water. Okay. Now the most common standards used to assess water quality: safety of human contact and drinking water, right? So as far as the common assessment qualities are, that is health of ecosystem, safety of human contact, and drinking water. So if we can drink water, if it is safe for us and if it is healthy for an ecosystem, then it is considered to be good. Otherwise, it is considered to be bad. Okay. Now environmental water quality, right? It is also called the ambient water quality, and it relates to water bodies such as lakes, rivers, and oceans, right? Environmental water quality means whatever water is available. Yes, definitely total water is available by the environment only, but it is considered that whatever water is flowing inside the lakes, rivers, and oceans, in those particular bodies, whatever water is present, if that water is good or bad, right? So that is called ambient water quality. Okay, ambient water quality, right? Now water quality standard for surface water varies significantly due to different environmental condition, ecosystem, and indeed human use. See, groundwater, surface water, both are different. Groundwater is difficult to access, whereas surface water is very easy to access. That means suppose we want a bucket of water. Now we will not make a well, right, to take groundwater for filling that bucket. Rather, what we will do, we will go to a nearby pond and we will fill the bucket of water. So if your whatever use you are doing of that particular water, if suppose you are you're washing your clothes in the pond, right, the water quality will be bad. But you cannot do the same in terms of groundwater. Okay, so groundwater and surface water are very much different as far as quality is concerned, as far as use is concerned, right? Now significantly the quality of surface water will vary due to human use. Okay, now toxic substances and high population of certain microorganisms can present a health hazard for non-drinking purposes such as irrigation, swimming, fishing, rafting, boating, and industrial use. Now yes, this is very important, because we may think that okay, the water that is non-drinkable, fine, we are not drinking, so we can use any water. It is not like that. It is not like that. We cannot use any water for doing anything. For example, if we use water having high salt content in irrigation, then what will happen? The total vegetation will die. Okay, if we swim inside water that is toxic, then what will happen? Your body will have that toxic thing inside you. Okay, similar happens to industrial uses also, right? So we should clearly know what type of water people are using before we use that particular water, right? Now this is the next slide about the quality of water again, and it is said that the conditions may also affect wildlife which use the water for drinking as habitat. See, we are human beings, we are far more evolved, we are far more developed, so we know that which water is good, which water is bad. By testing the water quality, we know that, right? That this is good, this is bad. But how the animals will know? The animals may not know, may not sense that which water is good, which water is bad. It may happen that they are drinking the water, but after a certain time they fall ill and they die. Why? Because the water may be toxic, the water may be poisonous, right? Okay, so the bad quality of water may also affect wildlife to a large extent. Now, modern water quality laws generate specified protection of fisheries and recreational use is required as a minimum and retention of water quality standard, right? Now, whatever water quality laws have been prescribed, they take care of the fisheries, right? That whether the fishes, whether the water in which the fishes are lying, that water is good or bad, that they will verify, right? And also it depends on the current quality standards. Okay, now there is some desire among the public to return water bodies to pristine or pre-industrial conditions, right? Most current environmental laws focus on the designation of particular uses of water body. In some countries, these designations allow for some water contamination, so as long the particular type of contamination is not harmful to the designated uses, right? Yes, see, the laws for maintenance of water quality, whatever has been formulated, right? What they do, they basically prescribe that okay, this particular water belongs to this particular is designated for this particular type of use. For example, suppose we are having a pond. Okay, now in that pond there are large number of fishes. Now the water quality standard laws, right? Suppose they are prescribing us that okay, fine, you can wash your clothes inside water. So if you are washing your clothes inside water, what happens? Different type of chemicals are moving inside water. Now if it is good for the fishes, then it's okay, but if it is bad for the fishes, after a certain period of time there are stringent laws which will actually restrict us by doing the same inside the water. Why? Because they will be harmful to the population of fishes, right? Now what they are saying, given the landscape changes, example land development, urbanization, clear cutting in forest areas, in the watersheds of many freshwater bodies, returning to the pristine conditions would be a significant challenge. In such cases, in these cases, environmental scientists focus on achieving the goals of maintaining healthy ecosystems and may concentrate on the protection of population of endangered species by protection of human health. Okay, so it is very difficult to return the actual quality of that particular water. As a result, we need to be concerned that we should use the water in such a way that the water is safe for the use of future generation. Okay, let us go to the next slide. Now these are the different indicators of water quality. Now we should know about each of these, right? The physical indicators is the first we are starting with. Okay, physical indicators, right? Now first is water temperature. If temperature of water is very cold, then it is not good for fishes. Also, if temperature is very high, then also it is not good for fishes, because what happens, if the temperature is high, then the dissolved oxygen becomes less. Okay, so it is not good. Specific conductance or electrical conductance or conductivity, right? This is very important. Suspended solids, very important. If large number of suspended solids are there, then the water quality is very bad. Okay, transparency or turbidity. What is the turbidity of water? What is the transparency of water? There are few chemical tests that we can do in actually the water, right, to determine its turbidity and transparency. Okay, now this is the main important thing. Whenever a person will come to your house to see whether you will buy Aquaguard or Kent or whatever, then he or she, what they will check, they will check the TDS of your water. Now what is the full form of this TDS? Total dissolved solids, right? This TDS of this water they will check. They will say that what is the TDS. Depending on TDS, you will just select the filter that you want to buy. Okay. Next is odor, color, taste, and chemical indicator. Okay. Now order color test is quite good. Chemical indicator means nothing but what is the pH of water, or what type of chemical analysis that we can do using that particular water. Okay. So these were the physical characteristics. Let us go to the chemical characteristics. And the very first point that we are having here is the pH. Right? I was talking about pH in the last slide. Then comes one of the most important thing, that is biochemical oxygen demand. Then comes chemical oxygen demand. Then comes dissolved oxygen. Very, very important points, you know very well. Then comes hardness of water, we have already spoken about. Then comes the heavy metals that are present. This is very important. Nitrates, orthophosphates, pesticides and surfactants. Whatever chemical species are present inside water, that is to be determined as a part of the chemical indicators. Okay. What next? Biological indicators. Now, as you can see, all these are biological names. First one is Epem heporeta, right? Second one is Plecoptera. Third one is mollusk. Fourth one is Trichoptera. Then Escherichia coli, that is E. coli bacteria. Then coliform bacteria. Then fathead minnow, and then mysid shrimp. Right? All these are biological species, the presence of whom is detected, that whether they are present in water or not. Presence of some of them are good, presence of others are bad. Okay, right? So these were the three indicators by which we can clearly see that what the water quality is. It is good or it is bad. Okay. So environmental water quality is basically determined by three factors: physical, chemical, biological. And we have seen that what factors are determined in order to know the quality of water, right? Now what we are having? We are having salinity of water, right? Now what is the meaning of this word salinity? Salinity means how much salt is present. See, salinity is the saltiness or amount of salt dissolved in a water body, right? If we are saying saline water, as we know that fresh water is very less, saline water is maximum of the 3/4 part of water that is present or not. Saline water is maximum. Okay. Now, this saline water, the phenomenon of saline water is known as salinity, and it is the measure of the amount of salt that is present in water, right? Okay, now salinity is salt in grams divided by kg of seawater taken. So as gram and kg are there, this is basically a topic of molality, right? This is clear from our knowledge of chemistry. Okay, this will be estimated in terms of molality, right? Now this salinity is a very important factor in determining many aspects of chemistry of natural waters and a biological process within it. See, many fishes are there which are actually specially made for saline water. So they lie in saline water only. If you make them live in fresh water, they will die. Similarly, if the fishes that are meant to live in fresh water, if you allow them to go to saline water, then they will die, right? So these are different biological processes. Also, it is a thermodynamic state variable that along with temperature and pressure governs the physical characteristics like density and heat capacity of water. Yes, if salt is there, salt is an electrolyte, right? Salt means nothing but NaCl. Now this NaCl is nothing but an electrolyte, okay, which is highly conductive in nature. Now whenever NaCl will lie in water, then we will find out that what this NaCl is causing, right? So definitely it will change the temperature, it will change the pressure, and it will also govern the density and heat capacity of water, right? So it is very, very important to consider that what the salinity of water is. A control line of constant salinity is called isoline or sometimes isohel, right? Okay, so this is very much important for us to determine the salinity of water. Now we are having alkalinity. But before going into the details of alkalinity, let us discuss one thing in detail, that alkalinity experiment we used to have in our BTech syllabus, okay? That is measurement of alkalinity of water sample. At this moment it is not present in our BTech syllabus, but it was a very good experiment, that measurement of alkalinity of water sample. Now what basically we people do while we measure the alkalinity of water sample, first we need to know the details about water. Now we need to know, whenever we take a general sample of water, what type of anions and cations are present inside that particular water sample, okay? If we go into the fact to find out that what ions are present inside this water sample, you will come up with the result that there are 3 different types of anions that are present in the water sample. Basically 4 different type of ions that are present in the water sample. Anions I am talking about, right? Because anions result in alkalinity or basicity. Okay. Now what these particular ions are, they are nothing but hydrogen carbonates, sulfates, chlorides and carbonates. Okay, HCO3 minus, CO3 2 minus, SO4 2 minus, Cl minus, right? Now among these 4 ions, hydrogen carbonate will be there, but carbonate will not be there. Why? Because carbonate will react with water to form hydrogen carbonate. So these have been reduced to 3 ions. Also Cl minus we will never get, so we'll be left behind with the other 2 ions, and due to which we will actually, due to hydroxide, bicarbonate and carbonate, we will get the alkalinity. Okay, so let us see how this works, right? Now alkalinity is the capacity of a water to resist change in pH that would make the water more acidic. We need to know what is alkaline. Do you know what is alkaline? What is the difference between alkali and a base? Anybody can tell me what is the difference between alkali and a base? It's a very basic question of chemistry that is asked in class 9-10 level. That what is the basic difference between an alkali and a base? People say acid base, some people say acid and alkali. Then is base and alkali same or they are different? Always remember, all alkalis are bases, but all bases are not alkalis. Again I am saying, all alkalis are bases, but all bases are not alkalis. Now why we are saying like this? See, alkali means water soluble base. Suppose we are having sodium oxide and sodium hydroxide, NaO and NaOH. Both are bases. Okay, NaO is a base, also NaOH is a base. But the problem is NaOH is a base as well as alkali, but NaO is a base but not alkali, because NaO is insoluble in water, but NaOH is soluble in water. Okay, so we need to know what is alkali, and alkalinity is basically the capacity. See, your water will become acidic. So if we want to stop this acidic behavior of water, what we need to know? We need to add some base. Now if whatever bases or whatever alkalis are already present in water that resist the pH change, okay, towards acidity, that is called the alkalinity of water, and it should not be confused with basicity, which is absolute measurement of the pH scale. So alkalinity is just present as it is in water, and basicity is somewhat more stronger parameter than alkalinity. Okay, so basically alkalinity is the strength of a buffer solution composed of weak acid and their conjugate bases. Fine. It is measured by titrating a solution with monoprotic acid such as HCl until the pH changes abruptly or it reaches end point where that happens. Okay, so basically weak acid and their conjugate base, I think you remember, it is acetic acid and sodium acetate, right? Together they become buffered solution, okay, which is called acidic buffer, right? And basically as alkalinity is measured by titration. Now how this titration will be done? It is simply titration with HCl solution, right? And where the end point will be colorless, right? See, water is alkaline. If you add phenolphthalein indicator, what will happen? It will be pink. So gradually whenever you will add acid, then the pink color will decolorize, and finally one time will come when it will be totally colorless. That time we will say yes, our solution is base free or alkali free and neutralization process have complete. Okay, alkalinity is expressed in units of milliequivalents per liter, which corresponds to the amount of monoprotic acid added as a titrant in millimoles per liter. Fine. Alkalinity of natural water is determined by soil and bedrock through which it passes. Yes. So basically we know that weathering of rocks and weathering of soil is a very important concept. So whenever water will pass over rocks, some portion of the top layer of the rock or the soil will mix with water, right? And it will result to alkalinities. That is very important to consider. Main sources of natural alkalinity are rocks which contains carbonate, bicarbonate and hydroxide compounds. Silicate phosphate are also present in rocks. so they may also contribute to alkalinity, right? This is also very important concept. Water alkalinity and pH are not same. Water pH measures the amount of hydrogen, that is acidity in water, whereas water alkalinity is a measure of carbonate and bicarbonate levels in water. Basically, we can say in a simple term that alkalinity and pH are not same, rather they are opposite to each other. Okay, alkalinity and pH are not same, rather they are opposite. Why I am saying so? Because pH means measurement of number of acidic ions, alkalinity means measurement of number of basic ions, pH means measurement of H plus ions, alkalinity means measurement of carbonate and bicarbonate ions. Okay, now for all water sources, it is the alkalinity that actually determines how much acid to use, not the pH. High alkalinity levels are actually good for aquatic life. Unlike most other measurements, high alkalinity is good and low alkalinity is bad. High alkalinity shows that the liquid has a capacity to neutralize high amounts of acid. As a result, pH levels becomes safely between 7 and 8. So high alkalinity means nothing but the pH level will be within 7 and 8. So it is preferable, if alkalinity is good, the water condition will be termed as perfect for the growth of fishes, right? So alkalinity is basically a very good concept and a very good thing. Okay, so boys and girls, we have seen in this lecture what the water quality indicators are, how we know that water is good or not for us, whether it is fit or unfit or what. We can see that people have seen. We have seen what the physical indicators are, what the chemical and biological indicators are. Also, we have seen that what is salinity of water, what is alkalinity of water. Now, we have come across the fact that alkalinity is a very important topic and it directly impacts the amount of living organisms that is present in water. Okay, so this was all for the topic which is called water. We have seen part 1 and part 2. In the next lecture, we are coming up with corrosion, right? So, thank you so much. Stay tuned, stay safe, and save water. Thank you.